Hi there. In this video, we're going to be talking about real numbers. In order to talk about real numbers, we have to talk about all of the different number systems that exist for our purposes. So the first set of numbers that we can talk about are the natural numbers, okay? And so the natural numbers are simply your counting numbers, okay? And so an example of this would be like 1, 2, 3, 4, and so on, okay? And so this is just a group of numbers. So if I say the natural numbers, these are the numbers that I'm talking about. Now the next set of numbers is the whole numbers, all right? So the whole numbers are your natural numbers, so that group of numbers, so the natural numbers and 0. All right, so if I write this out, I would write 0, 1, 2, 3, 4, and so on. Okay, so if I say a whole number, I know that that's going to include 0. All right, my next set of numbers is the integers. All right, now the integers, these are the whole numbers and their opposites. Okay. So this includes the set of negative numbers. All right, so when we say this, I'm going to write -3, -2, -1, 0, 1, 2, 3, and so on and so forth, okay? So, understand that, that what I'm doing here is that I'm taking one set of numbers and then I'm building on that set of numbers, okay? So the natural numbers exist within the integers. All right, the natural numbers exist within whole numbers, all right? Now, whole numbers also exist within the integers, all right? This group of numbers is going to exist in here, but the whole numbers do not exist within the natural numbers, okay? Because the whole numbers include 0 and the natural numbers don't, okay? All right, my next one is going to be our rational numbers, all right? So rational numbers are fractions whose decimal either terminates or repeats. Okay? And so an example of that, and you can think of like any rational number. All right, and I'm going to write out a bunch. All right, so I'm going to write out like 1/2. All right, that value as a decimal is 0.5, okay? And that decimal terminates, it stops, okay? If I were to write out, say, like 1/3, well, that's going to repeat. So 0.3, 3, 3, 3, and so on, 0.3 repeating, all right, that's going to be a rational number as well. Now, one thing to consider here is that every integer is also a rational number, okay? If I write the number, say, -3/1, well, that's simply -3.0, all right? And that decimal terminates, okay? So I can write any number as a fraction, but we got to make sure the decimal terminates or repeats. All right, so let's talk about something that doesn't do that, all right? We call those irrational numbers, all right? And so a common number that's irrational is the number, and this is where the decimal, it's the opposite of what a rational number is. So a decimal does not repeat and does not end, all right? It's just random numbers, okay, if you will. And so then from here, what we can say is that, an irrational number, like a common number that we think of is the number pi. All right, pi is an irrational number, 3.1415926, and that number is going to continue on forever and ever and ever and it's going to then become a these numbers are random. There's no order to this, and they don't repeat. Okay, so it's not going to end. It's not going to repeat. Just numbers like that. The number, the square root of 2, is also an irrational number. That number is 1.4142135623, and so on. Okay, and that number is not going to repeat. Okay, it's not going to end. It's just going to keep on going forever and be random. Another irrational number that we can say is the number, say, 2/17. Okay, so 2/17 has a decimal value of 0.1 1176470588824. All right, there's no pattern to these numbers of how they repeat or anything like that. So this is an irrational number. So now to put all of these things together, okay, to put all these groups of numbers together, to put your natural numbers, your whole numbers, integers, rational numbers, irrational numbers, then you have this thing that's called the real number system. All right, so the real numbers, all right, which is what we're talking about, is any number, okay, any number on the number line, all right, and that's any number that you can conceivably think about that exists, all right, and that's all encompassing. That includes the irrational numbers. It includes the rational numbers, the integers, the whole numbers, the natural numbers, all right, so any number on a number line. All right, the next thing that we can talk about are some of the properties of these numbers. Now, the commutative property is this. And when I say the word commutative property, I think of the word reorder, okay? So watch what I do here. By definition, here's what the commutative property means. It means A plus B is equal to B plus C, okay? It works for addition, and it also works for multiplication. I can say A times B is equal to B times A, all right? And what this means is, like, let's take a number, let's take like 3 plus 2, okay? We know that 3 plus 2 is gonna give us 5, all right? That's equivalent to us saying, well, what's 2 plus 3? And all I'm doing is I'm reordering. I'm just switching these around from one side to the next. And I can add numbers in any way that I want, any combination, and I'll still get the same thing. 2 plus 3 is also going to give us 5, all right? So as long as you add numbers, it doesn't matter the order in which you add them, but that you can reorder them to add them. And that's something that's pretty powerful later on in mathematics when you're like got a bunch of stuff that you got to do, and knowing that you can reorder something is pretty powerful. All right, and it also works for multiplication. Okay, so if I do 3 times 2, I know that's going to give me 6. Okay, that's equivalent to doing 2 times 3, which also is going to give me 6. Okay, now the next one I want to talk about is the associative property. All right, and the associative property means that we need to regroup, okay? That's the idea with the associative property. By definition, it works like this. A plus B plus C is equal to A plus B plus C. Now, I'm going to group my A plus B together, all right? I can also group my B plus C together, add all these things up, and that's okay, and I'll get the same thing, all right? It also works for multiplication, all right, where I've got A times B times C, and then that's equal to A times the quantity B times C. All right, so both of those are going to work. All right, so regrouping, and let's look at an example here. So let's look at, like, say 2 plus 3 plus 4 equals 2 plus 3 plus 4. Now, if I group my 2 and 3 together, all right, and I do that part first, and let's group the 3 and 4 over here. If I group the 2 and the 3 together, that's going to give me 5, and then add 4. 5 plus 4 gives us 9. Okay. Now, if I group over here, and I have to add the 3 and the 4 before I add the 2, that's going to give us 2 plus 7, which also gives us 9. So these two things are the same. All right. So regardless of what you have, you can group. If you're adding numbers, you can group them together. And that's okay. You're still, if you evaluate it, you'll get the same answer in the end. All right, let's do multiplication, and let's look at 2 times 3, that group, times 4, and then let's do 2 times the group of 3 times 4. So 2 times 3 is 6. Okay, do that part first, multiply it by 4. 6 times 4 gives us 24. All right, if I do this over here, 2 times the quantity, 3 times 4, that's really 2 times 12. 2 times 12 is going to give us 24. So same thing. All right, so you can regroup numbers using, using parentheses. All right, the next thing I want to talk about is this concept of an inverse. And an inverse is something that, like, undoes something. And we do this all the time when we solve equations. I like to use the word opposite, but sometimes the specific wording, we need to know how to answer those kinds of questions. So inverses, let's talk about the additive inverse. This is something, so you add a number to get 0? All right, so let's think about that. Like, let's say you had, by definition, it's this. If you have a, you would add, the additive inverse of a is negative a. A plus negative a is going to give you 0. That's the definition. All right, think of it like this. Think of like the number 7. All right, what would you add to 7 to get 0? All right, and that's the question. So 7 plus what is going to give you 0, and that would be negative 7. So negative 7 is the additive inverse of 7. All right, and even if you had a negative number, let's say you had like, say the number like 8, or I'm sorry, negative 8, what would you add to that to get 0? And that would be positive 8. All right, so additive inverses are just opposites of each other. The next one that we have when it comes to inverses is multiplicative. All right, and it's a number that multiplies to 1. Okay, so when we talk about the multiplicative inverse, and here's what we say. All right, if you had a, that a times 1 over a gives you 1. Okay, and that's the definition of what a multiplicative inverse is. So what we could do is say this. Let's take the number like 2, for example. If I multiply this by 1/2, I get a value of 1. Let's talk about how that works. And we got to remember how to multiply fractions. So if I write 2 as a fraction, 2 over 1 times 1 over 2, that's going to equal 1. And what we end up getting here is we multiply across. 2 times 1 is 2. 1 times 2 is 2. And 2 divided by 2 is 1. So 1 is equal to 1. All right, and that's how that works, okay? And all this is this thing called a reciprocal. And a reciprocal means that you flip a fraction. All right, so like if I had the number like, say, negative 3, my multiplicative inverse would be negative 1/3. All right, and if I multiply those across, negative 3 times negative 1 is going to give us, positive 3. 1 times 3 gives us 3, and 3 divided by 3 gives us 1. Okay, and that's how we do that. Now let's think of like a fraction. Let's think of the number like, say, 7/5. All right, the multiplicative inverse of this, what do I multiply this by to get 1? You simply just flip your fraction. We call that the reciprocal, but I'm going to multiply this by 5 over 7. All right, and that's your multiplicative inverse. All right, so 7/5 times 5/7, multiply across. 7 times 5 gives you 35. 5 times 7 gives you 35. 35 divided by 35, and that gives you 1. So that's what I got. So I hope you guys enjoyed this video. I know it's kind of a lot of like tedious, weird vocabulary and things like that, but good luck, and let me know if you have any questions. Thanks. Bye.